Welcome back everyone. We're talking about PLC to SCADA layer data transfers. There was an issue with the video that I had recently posted, so I wanted to make a part 2 essentially re-explaining some of the nuances between HMI and SCADA systems in this video and how you can make the right decisions to choose the platform for your specific operation or for your specific customer. Of course, if you haven't seen part 1, highly recommend it. There's going to be a link at the bottom, but ultimately you can also go into the channel and watch and find the video. So in this case, just as a quick reminder,
thank you so much for watching our channel. If you have a moment, I would truly appreciate if you could subscribe and like the video. If you could also leave me a comment as to whether the content is interesting for you, or if you would like to see something else in manufacturing industrial automation. It helps us tailor some of the future videos. I will also mention that we have a ton of different tutorials and articles that go way beyond the content on the Joltek.com website. If you need help on some of your projects, don't hesitate to reach out. With that in mind, let's get back to the video.
Imagine for a moment that we have multiple lines of various machines. This could be your packaging, it could be your process. It doesn't necessarily matter as to what the underlying control system is. A lot of these machines are going to have a PLC as well as an HMI. So PLC, this is going to be HMI. And there's going to be, of course, VFDs, I/O, and other devices on which the control system depends to execute the physical motion and transformation of product. Again, it could be creating boxes, it could be closing boxes, it could be creating the actual product, it could be machining. That does not necessarily matter for this specific example. But for a moment, picture that you have multiple lines where every machine has a PLC as well as an HMI. And of course, in the real world or in real environments in the industrial setting, you can have multiple PLCs, you can have multiple HMIs per machine, per area, per department, per manufacturing line. You could have an HMI that controls multiple machines, for example. Those are all nuances for a specific scenario. Now, your HMI and your PLC are going to be basically the control system for a local area. It is to some extent impractical to allow, for example, the HMI on this machine to control a process that the operator has no visibility over. It is, of course, there's going to be exceptions to that rule. If, for example, this operator needs to see what the downstream machine is doing, it is possible to pass data from this HMI to this HMI for him to be able to have a signal that will, again, consume the data between the two HMIs, but ultimately give a visual to that operator. That being said, as I mentioned in the previous video, both of these systems aren't going to be databases. They are not meant to back up enormous amounts of data. Of course, it is possible to use a PLC to buffer some of that information for a couple of hours, maybe a couple of days, depending on the stream. The same goes for your HMI systems. It is capable of displaying the data. It is capable of displaying historical information. It is very often capable of storing some of that information on a USB or an SD card, but it is not necessarily a SCADA in and of itself. A SCADA system is going to oversee a larger area. And again, how large of an area? Well, it depends on the application. It could be on a line-by-line basis. It could be on a department basis. It could be looking at the entire warehousing system. It could be looking at line 1, line 2, line 3, line 4, but it gives you an overview of the larger or bigger picture in that specific scenario. Now, where this becomes interesting in terms of projects, so when you purchase standalone HMIs or when you're paying for a machine that has standalone HMIs, in many instances, this is considered a thick client. So basically an HMI is nothing but a computer. Usually, again, on the Rockwell side, they're going to run Windows. Sometimes it's going to be Windows IoT, right? So that's going to be the more robust for the industrial side of things type of an HMI, but ultimately you have a full computer that runs the application, that runs some storage or some sort of a database. Again, how it is built is not necessarily extremely important, but imagine for a moment that every HMI is costing you $5,000 because it has all of those application runtime requirements. Now, if you start talking about a SCADA system, imagine for a moment that you have a server room where you have a rack where you can install a what's called a rack mounted server. And again, this is going to be a simple detail, but imagine that you have a server of 2U, which basically tells you how big in a general sense the server is, but you're going to pay $20,000 for this server. And again, it depends, of course, on the requirements, how much RAM, how much storage, how much CPU power you're putting onto that server. But in this question, well, you start wondering, why would I pay for a server and why would I now store the data into the server? It becomes uneconomical for me to purchase not only $20,000 of hardware, but also, of course, the licensing costs and the development costs and the engineering costs. Well, what becomes interesting with SCADA systems is that they also allow the distribution of what is called thin clients, right? So in this case, the HMI, as I've said, is a full-blown computer that could be replaced. So let's assume that this is thick client, with a thin client. So a thin client, as the name suggests, is going to be the opposite of a thick client and usually is going to come in substantially cheaper, right? So it could be $600 to, let's say, $1,400, depending, of course, on the size of the HMI and the capabilities. But what it's going to do is this thin client is going to maintain a near permanent connection to the server that is running this SCADA system, which is getting all the information from your PLCs into the server, again, into the application, and then servicing this information back to the thin clients. And so these thin clients are basically, again, HMIs, so they're going to be touch terminals, but they will only run a very small application. They do not require the entire capability of a computer. All they do is, like I said, run the application. Usually they're going to be Linux based because they're simply a lot leaner on that side. And so you can very quickly see that instead of having these clients all over your facility, because obviously the cost adds up, you will reach a break-even point where it becomes more cost-effective to run thin clients all over the facility versus using standalone HMIs, which are used to control separate pieces of equipment. And this is a very common scheme. So if you have worked on the Rockwell side, you have your factory talk view ME terminals, and those are going to be standalone. Depending if you select a performance version, you can connect to multiple PLCs. If you select a standard one, you can only connect to a single PLC. But as you scale that into Factory Talk View SE or Site Edition, you now have the capability of hosting the entire application on a server. And of course, a server is just a very powerful computer, but ultimately the runtime, or where the application performs the computations, is going to be on the server, and everything else in the field is going to be a relatively inexpensive terminal that you can then service from the central application. And so in terms of data, right, I want to emphasize this because I believe many facilities miss this very important point. When you have a standalone HMI that basically only talks to the PLC, it's rare that the HMI is going to talk to your VFDs or servos. Usually that's going to be the job of the PLC, right? So the PLC, again, using a network switch, is going to get all of that data, and then that's going to display on the HMI. Well, that's all fine and good, but once you start scaling to this enterprise solution via a SCADA, the problem becomes more often than not your network architecture. And so in this case, once you start having, for example, a managed switch, and you start adding all of these devices, right? Because remember, you need to tie in your PLC, you need to tie in your HMI, PLC, HMI. So a lot of different devices will start creating traffic on the network, and it's going to be extremely important for you to manage all of this infrastructure in order to be able to basically unlock some of the savings that I have mentioned on the thin client side. And a lot of facilities miss this. I've had a lot of different conversations because at this point IT starts to get involved and they start managing some of the server and SCADA architectures. So it's not always as clear cut or as easy to implement as one would basically describe. So if you're looking to go into that scale or into that direction, I would highly recommend having a lot of conversations between your IT and OT departments, lining up a very clear strategy and plan as to how you can migrate, but ultimately understand what value your SCADA brings, not only on some of these cost savings when it comes to hardware and software, but also value on continuous improvement, the advantage of being able to start the entire production line or the entire production area, the ability to see some of the historical data, the ability to store information that is or sometimes is critical for different entities. Like I worked in many FDA regulated sites, they would want to see data for the last 5 years on specific metrics. For example, SCADA becomes a very attractive option because it's a lot easier to store data, it's a lot easier to process data. And when I say easier, it's not only easier from an engineering standpoint, it is a lot less expensive because these servers are optimized for you to be able to put in hard drives of multiple terabytes versus your HMI, again, is going to have maybe a couple of just enough memory to store the data for, like I said, maybe a couple of hours, maybe a couple of weeks even in some instances, but ultimately you plug in a USB or an SD card and that's going to be the limit of that specific system. While your SCADA, very easily expandable, very easy to grow. You can add as many servers as you'd like depending on the load. So there's going to be a lot of different advantages and capabilities on the SCADA system that you do not necessarily get from your PLCs or HMIs when it comes to data, when it comes to applications, and when it comes to ultimately insights on how to make the factory better.